Hi dear students. Let's see this question that came in JEE Advanced Paper 2 Physics in the year 2018. The question is from the topic of Vernier calipers and Young's modulus, that is properties of matter. Basically somewhat similar to what we do in Searle's method, finding Young's modulus. So basically what's happening over here, there is a steel wire of diameter 0.5 mm whose Young's modulus has been given to us. A load of mass m has been attached. The length of the wire is 1 meter. There's a vernier scale that has been attached with the wire, uh, which has 10 divisions. Now, parallel to the or next to the steel wire or next to the vernier scale, there is a main scale with the least count of 1 mm. It's also given that 10 divisions of the vernier scale coincides with the 9 divisions of the main scale, which is a very standard data. Initially, the 0 of the vernier and main scale were coinciding. Now we put extra 1.2 kg on the wire, and so basically on this M we increase the load by 1.2 kg, and we have to find which reading of the main scale and vernier scale will coincide. Okay, so this is the question. Now if you try to pi, the value of pi has been given as 3.2. Okay, now if we try to analyze the situation, one main scale division has been given as 1 mm in the question, right? So one vernier scale division will be 0.9 mm because it was given that 10 vernier scale divisions equals to 9 main scale divisions. That means 10 vernier scale divisions will be 9 mm. So one main vernier scale division will be 0.9 mm, right? Now if you see, suppose this is the 0 of the vernier scale. This is the one division of the vernier scale. So that means this is 0.9 mm. This is the second division, this is the third division, and so on and so forth. This is the fourth division, okay, and this is the fifth division, like that. Initially, so this is the vernier scale, okay, and here we have the main scale. Here we have the main scale, right? So initially these zeros were at the same level. These both zeros were at the same level. So this is 1 mm, this is 2 mm, this is 3 mm, okay, and this scale is attached with the block, or we can say the wire, which is going to shift because of the extra load. Now if you see, this is initially at the same horizontal level, okay. Now first let us see how much will this vernier scale go down. Okay, how much will this shift below? So that we can find using the concept of Young's modulus. We have put an extra weight of 1.2 kg, so let's calculate this here itself. So we are going to say that tension will increase by 12 newtons. Tension upon cross section area, we'll use this formula. Force upon area is equals to Young's modulus into delta L upon L. So extra force is 12 Newton because when the mass was M, then already zeros were matching. So we are just trying to find the extra extension. So here 12 is the extra tension that will be generated. Upon cross section area is diameter is 0.5 mm. So pi into radius will become 0.25 into 10 to the power minus 3. This is in meters square. So 12 upon this equals to Young's modulus, which is 2 into 10 to the power 11 into delta L upon L is 1 meters. Okay, so when we solve this, we will get delta L as 0.3 mm. You can do the calculations. Put the value of pi as 3.2. You can do the calculations. It's not very difficult. So when the value of delta is 0.3 mm, that means the wire will go down, or we can say block will go down by 0.3 mm. And to the block, the vernier scale has been attached. To the block, the vernier scale has been attached. So since block goes down by 0.3 mm, so we can say that vernier scale will also go down by 0.3 mm, right? So we realize that this vernier scale is going to go down by 0.3 mm. Now you see, let's ask. So basically, if you think carefully, this 1 mm and this first division, this distance, slight difference between these two, this will be 0.1 mm because this is 1 mm, this is 0.9 mm. Similarly, this is 2 mm and this is 1.8 mm. So we can say that 2 mm was 2 mm was 0.2 mm below this division, है ना? ये 2 mm इस division के 0.2 mm नीचे था. वैसे ही this 3 mm was 0.3 below this third division. So basically what is going to happen? When this vernier scale will go down by 0.3 mm, these two readings will coincide. It is very easy to see. These two, because right now this is below राइट नाउ दिस इज अबव, ये वाला ऊपर है और ये नीचे है 0.3 mm से. तो when vernier scale will go down by 0.3 mm, these two readings will start coinciding, and hence we can say the answer will be 3, right? So basically we could have simply said कि जिस रीडिंग से coincide करेगा वो रीडिंग, let's say nth reading coincides, let's say nth reading coincides, तो shift की वैल्यू, मतलब अगर अपन फॉर्मली करें इस क्वेश्चन को, शिफ्ट जो आएगा वो जो रीडिंग कोइंसाइड करने वाली है इनटू 0.1 mm. ठीक है, जैसे अगर अभी तो 0th रीडिंग कोइंसाइड कर रही है, अगर ये वर्नियर स्केल 1, अगर ये वर्नियर स्केल 0.1 नीचे गया होता तो फर्स्ट रीडिंग कोइंसाइड कर जाता, अगर ये 0.2 mm नीचे गया होता तो सेकंड रीडिंग कोइंसाइड कर जाता, अगर ये 0.3 mm नीचे गया है तो ये थर्ड रीडिंग कोइंसाइड कर जाएगा, अगर ये 0.4 mm गया होता नीचे तो फोर्थ रीडिंग कोइंसाइड कर सकता. तो इसलिए अगर nth रीडिंग कोइंसाइड कर रहा है तो n into 0.1 mm will be equals to shift. Shift is 0.3 is equals to n into 0.1. So n is third. So we can say that third reading is going to coincide. Okay. So I hope you would have understood the solution. The answer for this question will be 3. That's it. Thank you.